Welcome to today's tutorial session. Today we have here y is equal to e raised to the power x, of which we have to differentiate. Now, e raised to the power x is an exponential function. So if you have a problem like this, just introduce len to both sides. Len is a natural law, so it's the same thing as logarithm. So introduce len to both sides. So we are going to have len y is equal to len e raised to the power x. Now, in logarithm, if you have a problem like this, the exponent can take its position before the log. So we have len y is equal to x len e. It is a property of logarithm. So now, since you have something like this, len e now becomes a coefficient of x. Okay, and now we are going to differentiate y with respect to what? X. Now y is an implicit, so whenever you are to differentiate y, we are going to have d over dx 1 over y. Whenever you are to differentiate a logarithm function, it is always f prime of x all over f of x. So we have d over dx 1 over y is equal to, when we differentiate x, we are going to get 1. 1 multiplied by len e, we get len e. What we are looking for is dy dx. So let us make our dy dx by multiplying through by y. We are going to get len e multiplied by y. By y is what? Our y is equal to e raised to the power x. So here is dy dx. So our dy dx is equal to len e multiplied by e raised to the power x. E raised to the power x. So now, anytime that you have len e, you can punch it on your calculator. Len e is equal to 1. So we are going to put 1 here. And our dy dx now becomes e raised to the power x. Now, the question was to differentiate y is equal to e raised to the power x. And now, after our differentiation, we have gotten our dy dx to be equal to e raised to the power x. So what can we learn over here? What we can learn over here is that whenever we have an exponential function, just pick the exponent. So our exponent is what? X. When we differentiate x, we are going to get what? 1. And multiply it with the original function. Because here, always whenever we differentiate an exponential function, we will still get the original function in our solution. So let us also, if you do understand, differentiate e raised to the power x squared. You can pause the video and differentiate e raised to the power x squared. So now, if you are to differentiate e raised to the power x squared, we are just going to pick the exponents. Okay, so when we pick the exponents, the exponent is x squared. So when we differentiate x squared, we are going to get 2x. Then we multiply it by the original function. So differential of e raised to the power x squared is equal to 2x multiplied by x squared. Thank you.